All right, Algebra 1B students, welcome back to videos. We are in lesson 9.5 today. We're going to start talking about a new way to solve a quadratic equation called completing the square. That's what it says underneath that guy, completing the square. And we're going to use that when we need to solve a quadratic equation that we cannot factor. Okay? For example, this quadratic equation right here. X squared plus 8x is equal to 14. Now we could turn this into a standard form, right? We should remember what that means. Getting it equal to 0 by subtracting 14 from both sides, now it equals 0. Unfortunately, there are no two numbers that multiply together to be 14, negative 14, and add up to be 8. Those don't exist. So we cannot factor that. So we're going to do what's called completing the square. Completing the square, okay? And you'll see what I mean when I get to the pictures down below. I do think completing the square is definitely easiest to understand if you think of it visually. Okay? So we're going to look specifically at the left side of this equal sign right here at x squared plus 8x. Okay? Now, if I were to give you that picture in algebra tiles, it would look like this. Okay, I don't know if you've used algebra tiles before, but that's the pictures that I'm going to be drawing for you. You're welcome to use algebra tiles in class when you're working on problems if you want to. Okay? This square right here, this blue square, is an x squared tile, okay, because its two side lengths are x and x. All right, and then I have 8 rectangles, smaller rectangles that are x units. They're just x because their side lengths are x and 1. So algebra tiles are all about area. The area of this blue guy is x squared. And the area of each one of these red guys is x times 1, which is x. So x, 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 x. I have 8 of those, and I have 1 x squared, right? Because I see 1 x squared right there and 8 x's right there. So I have 1 x squared, and I have 8 x tiles, okay? Now, if I rearrange those tiles and turn them into a square, it looks like this. Okay. So let's talk about what's here before we talk about what's missing. Hopefully you can see again. Here's my x squared tile from above. It's an x by x, and then I have x times 1 here. That's x tile, 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 x tile. There are 1, 2, 3, 4, 5, 6, 7, 8 of those. So I have still 1 x squared tile and 8 x tiles. Okay. Now, if we look at the big square, this big blue square here, all the way around, I'll make it red now too, I guess. I don't meant to make that blue, that's all right. We look at that big square. What I have in there in black, my x squared plus 8x tiles, doesn't quite fill in the square, right? I have all of this stuff that's not there. Yeah, and in order to fill in this square, I would need 16 of these little tiles. Okay, and I want you to look at why that is. Because I have 4 x tiles here, right? I make 4 columns going down. 4 columns. Column, 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 column. And the same thing with rows. I have 4 rows going across. So 4 columns and 4 rows means 16 tiles. So with just my x squared and my 8x's, I am 16 squares short of filling in the big square that I want. I'm 16 units. This might maybe should say units. I'm 16 units short of filling in this big square that we see here. Okay. Now, what does that mean for our equation? Well, completing the square, as we call this, means completing just what we're talking about here, this big square. And how many extra units would we need to have? We need to have 16. So if we translate this back to our equation, this blue square, algebraically, if you remember, we had a square here that had x and x as its dimensions, right? And then I had 4 x bars across the top, and each one of these was 1x, 1, 1, 1, 1. And the same thing here, 1, 1, 1, 1. So each of the sides of this big blue square has x plus 4 as its side lengths. X plus 1, 2, 3, 4. X plus 4, okay? So I've got x plus 4 up here, and I've got x plus 4 over here. So the area of this square, if we remember, the area of a square is just the side length multiplied by the side length. So that area is x plus 4 times x plus 4. But hopefully we remember that x plus 4 times x plus 4, if you're timesing something by itself, again, you can just say squared. Okay, so again, we're getting back to this whole squared business, and you'll see that come together here in just a minute. Okay, so x plus 4 squared would be all of this blue area here, right, that I am trying to fill in. That's x plus 4 squared. Okay? But we were 16 units short of that blue square, right? Remember these 16 units that we were missing right here, right? This was 16 squares, 16 units are missing. We're 16 units short. In math terms, that should sound like a minus sign to us. Okay, it should sound like a minus sign. So the 8 x's plus an x squared that we started with, the x squared plus 8x that we started with, is really equal to x plus 4 squared, that big blue square, but minus 16 units. Okay, because we have a big blue square that we could make using our x squared and our 8x's, but we're 16 units short. We're 16 units short, so we say minus 16 right there. Okay. We're 16 units short. So it's minus 16. X plus 4 squared minus 16. Let's complete the square again just so we see this process. With x squared plus 4x's. Right, so I'm going to draw myself some algebra tiles. I suggest you do the same on your paper as well. Okay? Draw yourself these algebra tiles with me. Okay, I'm going to make an x squared box here. That's my x squared tile. And then I have 4 x's. Right, I got 4 x's to distribute into my square. I think it makes the most sense to put 2 of them here, and then 2 of them right here. Split them up equally. All right, so now I'm trying to complete this blue square here. And let's see, what are the side lengths of my blue square now? Well, this is an x. And these are each 1 and 1, so it's 2. So I have x plus 2 and x plus 2. Okay, so my big blue square's area is x plus 2 squared, because I had x across the top plus 2 units and x plus 2 along the side as well. X plus 2 times x plus 2. But I don't quite have all of that filled in. do I, this blue square? I'm missing something right here. What am I missing there? Well, I'm missing 1 block, 2 blocks, 3 blocks, 4 blocks. I'm missing 4 blocks, so this is a minus 4. Minus 4. Okay, so x squared plus 4x is equal to x plus 2 squared, but minus 4 because we're 4 units short of filling in that square. This process is called completing the square. Okay, now, as I said before, I suggest you use the pictures. Draw yourself some tiles, use your pictures, but if you really don't want to do that, you really don't like the picture idea, here's algebraically what this means. Okay? If you want to, quote-unquote, complete the square for the expression x squared plus bx, just means x squared plus some number x, 4x, 8x, 10x, 12x, whatever it is, you can rewrite that as x plus, and then here's a b divided by 2. A b divided by 2. I want you to notice, if I go back up real quick, that x squared plus 4x became x plus 2, because 4 cut in half gives me 2. And the same thing up above, x squared plus 8x became x plus 4 squared, because 8 divided by 2 is 4. So you cut your b number in half, b divided by 2, and it's x plus b divided by 2 squared minus whatever that b divided by 2 number was squared. And so, for example, when we did this, we cut the 4 in half to get 2, and then notice that here, 2 squared equals 4. And the same thing here, 4 squared equals 16. All right. So x plus b over 2, b divided by 2, that quantity squared, minus this number, b divided by 2 squared on the end, because we are short some units to fill in our square completely. All right. Now you might see in your homework as well something where it's an x squared minus bx, like x squared minus 4x. That process is exactly the same, except now this sign here would be a negative. So this would become x minus 2 squared, and then a minus 4 at the end. Okay. So just be careful of the negative. If it's negative, it needs to be a negative inside the parentheses with the x as well. All right. Now, one more thing we need to do before we're done is go back to this whole idea of solving a quadratic equation using completing the square. Okay, we're going to solve this quadratic equation, and then we'll be done. And this is the kind of problems that you will be seeing in your homework. Okay, solve this quadratic equation. Now you will notice that right now, this is not in standard form, right? All before break, we've been talking about making sure that our quadratic equations are equal to 0, unless we're going to complete the square. Okay, so when we complete the square, we don't need that, because we would like this on the left side of my equal sign, because we know what to do with that. Right? X squared plus 4x. Okay, x squared plus 4x. So we've already completed the square on that up above. So if you want to see me complete the square with that, go back up above. I'm just going to tell you right now it's x plus 2 squared, and then a minus 4. Okay, that is still equal to 20. So now we bring the right side of our equal sign back in, and we have x plus 2 squared minus 4 equals 20, and our job now is to solve for x. The good news is we don't have to factor anything or anything like that. We can just solve using our algebra skills. So step 1 would be to get rid of the parentheses. Get everything away from the parentheses, which is this minus 4 here. So I'm going to add 4 to both sides first. I do expect you to be writing this down with me in your notes. so that you know the process to follow when you need to solve these on your own. That's now gone on the left side, and all I have left is x plus 2 squared equals 24. The next thing that I want to do is get rid of this squared exponent right here. I want to get rid of something squared, so I'm going to do the opposite of squaring something, which is to square root it. Square root. I'm going to square root both sides of this equation. That's going to go away. That's also going to go away. What's underneath is going to stay the same. So it's going to say x plus 2. X plus 2 down there. And then the square root of 24, if we use our calculator for that, square root of 24 is equal to 4.9. However, whenever we take a square root, we should remember there are two possible answers. So it could be 4.9 or it could be negative 4.9. X plus 2 equals negative 4.9. And you will get different answers for these two. Okay, so please don't forget that whenever you take a square root, you have a positive and a negative 4.9. Okay? Now, to solve these for x, as we've been doing before break, we just simply minus 2 from both sides, minus 2, minus 2, minus 2 everywhere. And we get that x equals 2.9 or x equals negative 6.9. And we're done. We've solved the quadratic equation by doing what is called complete the square. Complete the square. Okay, if you have questions about that process, please make a note to ask me in class. That's all I have for you right now. I'm not going to belabor the point. This has been a long video as it is. Hopefully it made sense. If you have questions, ask tomorrow. Otherwise, I will see you in class. Have a wonderful night.